All right, so we're looking at polynomial and rational inequalities. So we've solved quadratic equations previously, but now we're looking at quadratic inequalities. Remember your inequality symbols. So we're talking about using those instead of equals. Don't forget how your parabola is set up. You know, it's either going to be a U, it's either going to concave up or concave down, that upside down U. So we have these points right here where your parabola is equal to 0. Above those points, everything's positive. Below those points, everything's negative. So we have these intervals that are created that we have, you know, your graph will behave positively or negatively. And so that's going to determine what our answers will be. And you'll see what I mean in a second. So first problem, we have 2x squared plus x is greater than 15. So we always want to set one side equal to 0 because we want to be able to compare our expression to 0. So the first thing we do is subtract 15 from both sides. 2x squared plus x minus 15 is greater than 0. All right. So the reason why we're comparing it to 0, because if something is greater than 0, it's positive. If something is less than 0, it's negative. So we want to know when is the equation positive? That's what we're asking here. When is 2x squared plus x minus 15 positive? When is it greater than 0? All right, so the first thing we want to do is figure out when it's equal to 0. Remember those 2 points that I showed you on the parabola? That's going to be where the graph or where the equation is equal to 0. That's going to help us set up our intervals. So we want to know when is the equation equal to 0. So you set it equal to 0 and solve for x. So I decided to factor. But always remember that if you're not comfortable with your factoring skills, you always can use the quadratic formula. Still get the same values. So I got x equal to 5 over 2 and x equal to negative 3. Questions? Everybody all right? All right, so like I mentioned, we're going to use those values to help us set up our intervals. And let me erase this down here. All right, so our first interval, negative infinity to negative 3. Second interval, negative 3 to 5 over 2. And then our third interval is 5 over 2 to positive infinity. So those values we will use to help us to set up our intervals. And so let me erase this stuff so we can walk through it. So we would create this chart. Now, it's not mandatory that you create the chart. It is to your benefit, though, if you set up this chart so that you'll be able to easily get your answer and examine what the answer would be. So notice over here we have your intervals, test value, and then the behavior of the graph. And then we're going to fill out the chart accordingly. Up here, I've already set up the intervals. We just finished mentioning is negative infinity to -3, -3 to 5/2, and 5/2 to positive infinity. So don't forget, you'll always use parentheses on your infinity signs. Remember our interval notation, we talked about parentheses will always be on your infinity sign. And then what determines whether we have parentheses on our numbers or not is our greater than symbol. Remember, it's the or equal to that allows us to use bracket. Here, because we just have a greater than symbol, we're going to use parentheses. So parentheses on the -3 and the 5/2. All right, any problems? All right. I'll do it in purple. Yeah. So now we need test values. You just need any value that's in this interval. So I'm choosing -4. Any value in this interval, choosing 0. And then any value in this interval, I think I chose +4 last time. Let me see. Yep, I did. All right, but it doesn't matter. I'll just going according to my notes though. It doesn't matter what value you choose. The goal is to figure out how does your equation behave. So in other words, am I getting a positive value or a negative value? That's what you want to know. Am I getting a positive value or negative value? And so each one of these intervals will depict a certain behavior. I'm going to scroll back down, but going back to our diagram, remember right here is everything above this was positive, everything below is negative, everything above is positive. So everything is going to behave in that interval the same way. So all you need is one test value to figure out how the graph behaves. So now you plug in those test values. And I chose to use my factored expression. You can just plug it into the equation or use the factored expression like I did. And plugging in -4 right here. And I just kept it as the signs because depending on what number you chose would determine what number you get, but it's not about the number, it's about the sign. Are you getting a positive number or a negative number? That's what really matters. So that's what I emphasize here. So plugging in -4, I end up getting negative times negative, which ends up giving me positive. Plugging in 0, I ended up getting negative times positive, negative number times a positive number, which would give me a negative number. And then plugging in +4 down here gives me a positive number times a positive number, which would still be positive. So I'll give you a chance to write that down before we go any further. Remember, your goal is to figure out how does your graph or how does your equation behave within these intervals. Are you getting positive values or negative values? All right. So how do we know what the answer is? You go back to your original expression. Remember, we want to know when is our expression positive. So we see that, oh, what happened here? All right. So we see that we have positive responses right here for these two intervals. So our answer is negative infinity to -3 and 5/2 to positive infinity. All right, questions, questions. Or we do it again. All right, now scroll up. All right, so next one, x cubed plus x squared less than or equal to 4x plus 4. Once again, the move to make is to make sure that one side is equal to 0. And so that's what I did right here. Subtracted 4x and subtracted 4 from both sides. And that gives me x cubed plus x squared minus 4x minus 4 less than or equal to 0. And so now we're looking at, because it's less than 0, we want to know when is this expression negative. Give you a chance to write that down. All right, so the process is still going to be the same. You set one, set it equal to 0. Now you want to solve for those intervals. So you set it equal to 0. I have 4 terms. So I'm factoring by grouping. Group together the first 2, group together the second 2. Pull the GCF out of each set of parentheses. So x squared is what I pulled out of the first set. Negative 4 is what I pulled out of the second set. Leaves x plus 1 in the parentheses. Extract or factor out x plus 1. That leaves me with x squared minus 4. Then x squared minus 4 factors into x plus 2, x minus 2. And so set each one of those factors equal to 0. Solve for x. So we have x equal to negative 2, negative 1, then x equal to negative 2, and then x equal to positive 2. All right. Make sure we're okay before we go to the next step. Okay, so set up your intervals. And of course, your number lines set up in order, negative 2, negative 1, and positive 2. All right, so first intervals, negative infinity to negative 2. Second interval, negative 2 to negative 1. Third interval, negative 1 to positive 2. Fourth interval, positive 2 to infinity. All right. Any questions? And we see that our chart is still set up the same way. We have our intervals, test values, and the behavior of the graph or behavior of your function. All right, so parentheses on your infinity signs. Remember, that's always going to be the case. But this time, it's bracket because of the or equal to symbol. So we'll use bracket on each one of our numbers.
Wait, I'm sorry, why you said we use brackets?
Or equal to.
Okay.
Yep. So remember the last one we had was just the greater than symbol. If that had greater than or equal to, that line down here, then we would use bracket here as well.
Okay.
All right. Wait. Oh no, what did I do? Hold up. All right. Sorry about that. Erase this. Where it go? There you go. All right. So right here. All right. Everybody good before we choose some test values? All right. So as far as our test values go, it just has to be anything in this interval here we're looking at less than -2. So anything less than -2, you can actually choose -100 if you want. You're still going to get the same result. Remember, all we want to know is our value going to be positive or negative. So choose -3 here, in between -1, -2, -1.5. Here I can choose 0 and then +3. All right. Then plug those values in. Once again, I decided to use my factored expression just because it's easier as far as calculation. If you want to use the original, which is this, then you could. But either way, the result, are you getting a positive or a negative value? So plugging in -3, I end up getting negative times negative, which is still negative. Let me go with green. All right. Next one, I have plugging in -1.5, negative times negative, which will give me a positive. Plugging in 0, positive, and negative is negative. And then that last one, plugging in +3, I get all positive, and the result will be positive. So notice how in both of our first two examples, we're looking at our alternating signs. That very well may happen with all the problems that you deal with in this section. What you don't want to do is do this one, the first one, then just assume all of them will alternate, because if you made a mistake on the first one, that means you would make a mistake on the rest of them. So you always want to make sure you're actually going through the process. But, for those of you who are going to move on to calculus, there's no guarantee that it will always alternate like that. Depending on what's going on, depending on the interval that's established, that's why you actually go through the process and make sure all your values are correct and things like that. So you can never assume that your signs are going to alternate. All right. Any questions before we look to see what our actual answer is?
I'm sorry, you also said that if the greater sign has the line at the bottom, it will have a bracket.
Mm-hmm.
Okay, thank you.
Yeah. So that's where we use our brackets right here.
Okay.
Yep. Mm-hmm.
Thank you.
Yep. So whether it's less than, I'm just reiterating this for the class. So, and if you, and remember, this comes back to our interval notation. So less than or equal to, greater than or equal to will give you brackets. If I can write. But less than and just greater than, those two numbers, those two symbols will give you parentheses. So it's this line that's under here that lets you know you should have bracket. All right. So finish it off. Okay, how do we know which one's our answer? We want it less than. We want to know when is our graph negative. So we go to our chart and we see we got negative here. Whoa, not there. And negative right here. So that's when our answer, those two intervals are our answer. All right, questions, any questions? All right, can we go to the next one? Everybody all right? All right, rational inequalities. Pretty much going to be the same process. So this is our original expression, x plus 3 over x minus 7. And we want to know when is it less than 0. All right. So now to establish our intervals, remember last time we had to establish our intervals by setting our equation equal to 0, then solving. Well, here to establish our intervals, we're going to set the numerator and denominator equal to 0 to solve. So set x plus 3 equals 0 is our numerator. Get negative 3, and then x minus 7 equals 0, that denominator, and that gives us x equal to 7. All right. Set up your chart. Negative infinity to negative 3, negative 3 to 7, 7 to infinity. Once again, the chart setup is the same. We have our intervals, test values, and then behavior at the bottom. Parentheses on our affinity signs. And we have the less than symbol with no or equal to, so that means we'll use parentheses on the negative 3 and the 7. All right, test intervals, negative 4, 0, and 8. All right. So just like before, take those test values, plug them into our expression. This time our expression is x plus 3 over x minus 7. So took negative 4, plugged it in. That gives me a negative number over a negative number, which is a positive number. All right. Plug in 0. Positive number over a negative number. That'll end up giving me a negative number. And plug in positive 8. That'll be positive over positive, which will be positive. Make sure we are okay. All right, so now what our answer is dependent upon what our original symbol was. We're looking at less than, so we want to know when is this expression negative, and that's right here. So our answer is -3 to 7. I think I'm gonna put this answer down here somewhere. I don't want that big. All right, any questions? All right. Scrolling up to the next one. Everybody good? All right, so this next one, we have x plus 1 over x plus 3 is greater than or equal to 2. All right, so we notice that we have 2 on one side. The first move we want to make is to set one side equal to 0. Oh, what happened? Okay, there we go. So subtract 2 from both sides. You know, if we were to do that, that gives us this. And I'll just erase that just to make sure we're okay with the process. Don't forget, whenever we're adding, subtracting fractions, we need a common denominator. So common denominator is going to be x plus 3. So we need to multiply x plus 3 to the top and bottom of that 2 over 1. That's what we do here. All right, so now because of that process, we're able to bring it together and make it one whole fraction right here. So we have x plus 1 minus 2 times the quantity of x plus 3. Don't forget to distribute not just the negative, but also, not just the 2, but also the negative. A lot of times people forget to give the negative or attach it as a part of the distribution process. So that will give us -2x minus 6. Then combine your like terms in that numerator, and that'll be -x minus 5. So our new expression is x minus 5, -x minus 5 over x plus 3 greater than or equal to 0. me a chance to finish writing that. All right. So once again, we want to set each piece equal to 0. Numerator and denominator equal to 0. So negative x minus 5 equal to 0. Equal to negative, is x equal to negative 5. X plus 3 equal to 0. X equal to negative 3. So that's going to help us set up our intervals. All right. We'll come back to that in a second. So now we want to, just like before, establish our parentheses, brackets, whatever we need to put on our intervals. We know our intervals. Erase this stuff like before. We know our intervals. It's going to be negative infinity to negative 5 to negative 3, then negative 3 to positive infinity. So now we want to establish what should have parentheses, what should have brackets. So parentheses will always be on your infinity signs. Now, because we have the or equal to symbol here, that means we're going to use bracket. But when I look at this denominator, I cannot have 0 in the denominator. And that's this part right here. That's what I'm saying right here. I cannot have 0 in my denominator. But this is when the denominator is equal to 0. So because of that, you have to use, I'll go ahead and just put the symbols, parentheses here on your negative 3. Once again, you cannot have 0 in your denominator. 0 in your denominator is undefined. So that's why you cannot use brackets for the negative 3. Now the negative 5 will get the brackets, as we should, but we'll use parentheses on the negative 3. Once again, it's all about what the parentheses and brackets mean. Remember, your bracket mean you can include that as a part of your solution set. Parentheses mean you cannot use it. And remember, we cannot use negative 3 because when I plug negative 3 into my equation, it gives me 0 in my denominator. All right. Make sure we're okay before we go any further. All right. So now, outside of that piece, we're going to do the same thing, choose some test values, and then plug them into our expression. So -6, -4, and 0 is what I would choose. Let's see, that's what I chose. Yep. So plugging in -6, and you end up getting a positive number over a negative number, so that's negative. Plugging in -4, I get negative over negative, which would be positive. Plug in 0, I get negative over positive, which is negative. All right, any questions before we get our answer? All right, so this is greater than, so we want to know when it's positive. All right, why does it keep popping up? Okay, there we go. And so this is the spot where it's positive. So our answer is -5 to -3. And I guess I'll put that right here. All right. Questions, questions, questions.
Can you go a little bit down? I haven't copied.
Yep,
Thank you.
not a problem.
Thank you.
Yep, not a problem at all. Where'd it go? All right, so that is it for that's all they're asking of you in 3.6. Time is 11:50. So this is what we can do. We have one more section, then we'll be done with chapter 3. So let's look at what we're doing. We have Monday, Wednesday. So we will look at doing 3.7. I'll hold off and do 3.7 next class. And Wednesday, talking about next week, will be a review. And on Monday, we'll talk about how we're going to do an assessment for this chapter. So we'll talk about that on Monday and have all the details and everything for you. Outside of that, questions on anything before we close out today and go into the weekend. So questions on anything I said today, anything before, anything said today, anybody?
I do have a
Did you
question.
post a class from last week?
Yes, I sent them out from last week. Didn't send it from last class though. Last week though. I sent it out from, I think I sent it Monday when I sent it out.
Okay.
Yeah. Yeah, you should have got those. If you don't see them, let me know and I can shoot the email to you again. It's not a big deal.
I do have a question, Zari. Are we gonna have a proctor test? Any of these tests?
It's probably going to be, well, we know we're going to do, our final exam is going to be proctored. Our final test is going to be proctored for sure. Now, we didn't do chapter 2, so we're probably looking to do this one. And so that's why I said we're going to talk about the details on that next class, because I do different things with it. So I have all the details for you about that on next class. So that will probably be our proctor one, because we didn't get a chance to do chapter 2 proctored at all. So
Okay.
yep. So we'll talk about dates and how we're gonna do it, points and all that stuff like that.
Okay. Thank you. I have another question. We didn't do part 3.2.
Don't worry about it. You'll be all right.
Do I have to do it on my math lab?
Matter of fact, it can be extra credit. 3.2 can be extra credit if you want to do it. If not, you'll be all right.
Are there any sections that we do not have to do on math lab, or just 3.2?
As of right now, just 3.2. We've done everything else.
Okay. Thank you.
Yeah, not a problem.
And I emailed you, but I don't think I ever got a reply. I needed you to open some assignments.
When did you email me? You know what day?
I don't know what day, but I know it's like last week.
I'll look, because I've responded to all my emails from last week, so I'll take a look.
Okay.
Shoot me that email again. Yeah, because I missed it or it didn't get to me. But yeah, shoot that email to me again.
Okay. Thank you. Have a nice day.
All right, thanks. You do the same. And anybody else? All right. So, as always, try the stuff out. See if you have any questions. On Monday, section 3.7 is not that long, so you'll have opportunity to ask questions on Monday as well if you have them. So feel free to bring them, and we'll go from there. All right, thank you. Y'all have a nice one. Everybody take care.
Bye. Have a good day.
All right, thanks. You the same.